There's a lot of buzz around gRPC right now. The biggest thing I hear is that it's confusing and people aren't sure when or even how to use it. In this video, I'm going to introduce gRPC, show you how to set it up, and how to consume a gRPC service. We will also discuss when gRPC might be the right choice and when it probably isn't the right choice. The source code for today's video is available to download using the link below in the description. You'll also find links there to sign up for my mailing list and for my Patreon. If you're a Patreon member at the $10 per month level or higher, as a special thank you, I am giving you a gRPC cheat sheet to make your life a little easier. It is a cheat sheet I've been using to help me develop my demos. Just make sure you get it soon. The cheat sheet will only be available from now through the end of October. After that, it goes back in the vault. Now, if you haven't come across me before, my name is Tim Corey, and it's my goal to make learning C# easier. One of the ways I do that is by teaching context. There's a lot of tutorials out there that teach you what to do. I go a few steps beyond that to show you when to do it, why you should or should not do it, what pitfalls to avoid, and what the best practices are. Basically, I get you ready for the real world. If that's the type of training you're interested in, subscribe to my channel and hit the little bell icon to be notified when I release new videos, which is about twice a week. Now, before we move over to Visual Studio, let's briefly talk through what gRPC is. gRPC is a method of web communication between services. Think of it kind of like an API. It responds to requests across the web and gives the caller back the requested information. The differences are in how it is set up and how it transports the data, at least the big differences. gRPC relies on a known configuration that is shared between the client and the server. Think of it like a contract. These contracts are called protocol buffers. The other big difference between gRPC and an API is that gRPC communicates using a binary stream. This is much more efficient than a web server, which can use JSON or XML. Now, there are other differences, but those are probably the biggest two. Let's build a gRPC server and client, and then we can discuss the other differences in the context of our application. So let's go to Visual Studio. We're going to start by creating a new project. And in the search box, let's search for gRPC, and we'll find gRPC service. Now, this is a .NET Core 3.0 item, so you'll have to have .NET Core 3.0 installed, which, as of the time of the recording of this video, it's not quite out yet. It's going to be out soon, but by the time you watch this video, it will be out, so you should be able to get it for especially Visual Studio 2019. So gRPC service, and hit next. And I'm going to call this first one gRPC server. That's the project name. And we'll call this gRPC demo. And the reason why is we're going to create a a server project and a client project. And while they'll be in the same solution, they will not directly know about each other, meaning there's going to be no references between the two. I have been tempted to just do two separate solutions, just to make it very clear that these two don't talk to each other directly. But I think it's going to be easier for us if we just do one solution, and I just make sure I mention that a couple of times. So let's create the server. And it's going to say, hey, you want to create a gRPC service, no authentication, and we're not going to enable Docker support. So create the gRPC server. And this is what it creates for us. We have a Protos folder and a Services folder. So this is the server side of gRPC. This is the equivalent of a web API where it sits and listens for calls. That's the same thing this is going to do. It's going to sit and listen for calls. So let's talk through the various pieces of this. First, let's look at the proto file. This is something new that you probably haven't seen before. Now, gRPC, it stands for Remote Procedure Call, RPC. The G doesn't technically have a reason for being there, except the common assumption it stands for Google, because Google's who actually came up with this originally, although it is an open standard. So gRPC protofiles are the way you define the contract between the server and the client. To start off with, we have this syntax equals proto3. You're going to leave this alone. What this does is it says use the latest proto syntax or schema. And so that's proto3. This option right here just specifies the namespace for this particular proto. And we're using the namespace of our gRPC server, and that's fine. The package is the name of our package if we want to rename it. So it's greet. And then we have the service and 2 messages. Let's talk through messages first. So a message, think of it kind of like a definition for a model in C#. You're just defining a file or a class that has a bunch of properties in it. Now it's a little bit different in how you do it. You say message, not class, and you give it the message name. That can be a name you want it to be. Then inside curly braces, you specify 0 or more properties like so. String name equals 1. Now what this 1 is it indicates the order in which this property goes. So the next one will be 2, the next one will be 3, after that's 4, 5, 6. It counts up. That's all it does. So we have a message and another message. The reason they defined 2 here is because we're going to take in one type and return a different one. So when you call the say hello method remotely, so the client says, hey, remote server, I want to say hello, they're going to pass in a hello request, which is just one item inside of that request. It's just name, and it's of type string. This say hello method, when it runs, will return a hello reply message, which just has one item in it, which is a string and it's named message. Okay, so those are our 2 objects, one to be sent in, one to be sent back. Up here in our service, this is where we declare the greeter service. So this is a service that this particular proto is going to talk about. And it says, okay, RPC, that indicates this is a thing you can call, a remote procedure call. And so it's a method, essentially, and it's say hello. You pass in the parameters, which you just give it one parameter, not multiple. That's why we have this object always. And inside we can define 0 or more items. And yes, you can nest objects inside of this hello request. So you can have a complex object just like you could as a model in C#. So the say hello is a method. Here is the data it's going to receive. And then here is the data type it's going to return. Now, if you were in C#, you might write this as public hello reply. And then the name would be say hello with a hello request with the name of input, let's say. And then you have your curly braces. That's the equivalent C# code for what this is doing. Okay, it's pretty close. Okay, so now that's what this is doing. And we're gonna see this a couple times so you kind of get a better grip on this. And I will recreate this step by step as well. So if you're still going, don't worry, we'll get there. We have to explain all of it first before we can then start thinking about pieces of it. So this is the proto file. This is our contract. Now we have on the server side this service. So this is the greeter service. And so it says greeter service, which is a class. It implements inherits from greeter.greeterBase. Okay. Now, if you notice over here, the package is called greet. The service is called greeter. This is actually used for something different, but we pull from the service name greeter. Okay. So we say greeter, that's the service name. Okay. So right here, service name is greeter. So we pull from greeter.greeterbase. Now you may say, where does that come from? I don't see anywhere where it says greeter base. And you are correct. In fact, if we hit F12 here, we get this, greet grpc. That's where that greet comes in. So greet grpc is a file name. If you look at it, it's stored in the obj/debug/netcore app 3.0/greet grpc.cs file. This is a generated file. It says designer generated file or code. So think of this kind of like what happens with WinForms, where when we drag and drop a button onto the form, behind the scenes in a hidden file, it's writing C# code. Well, the same thing is true here. It's just that it's being stored not even in our project, it's being stored in the obj folder, which is something that gets regenerated every time you rebuild. So this file right here creates a whole bunch of code that we can then use. One of that is right here, public abstract partial class greeter base. And notice it declares a say hello method. Now notice all the stuff that's going on here. So it says public virtual global, couple of semicolons, and then system.threading.task, global, couple of semicolons, grpc server.hello reply. There's a lot of stuff that's writing for us about what's happening. But what this does is it creates all of the setup stuff for us behind the scenes. It regenerates that automatically. This is both a benefit and a curse of grpc. It's a benefit because it makes it really simple. We don't have to write this code, which as you can see is quite ugly. However, if something goes wrong, it can be somewhat of a pain. And believe me, when you first start working with grpc, something will go wrong. Now, most likely, in fact, 95% of the case, maybe 90% of the case, it's going to be your fault. That PDF cheat sheet I talked about, I'll walk you through all the different things in there, but one of the things that I have a section on is, here are the things that could go wrong, and here's how to fix those. Because I ran into all of these issues as I was building my demos. I'd get a demo working, I think, cool, I got through all my issues, I'd try it again, and things would break or not work. That's because that generated file wasn't quite right. And so I had to rebuild it after I made some tweaks in the system. Now, one time, just so you know, I did have to restart Visual Studio. That solved one quirky issue I was having. So there is a case for where it might be the tooling issue. This is a brand new type that is just coming out in .NET Core 3. So there are definitely some hurdles to get over. However, most likely the issue is something that you forgot to do because there's a lot of little quirky areas to configure this. Okay? So, but just note that's where this comes from. And you have to inherit from greeter base or the base of whatever type of service you're creating. Okay? So now we have a constructor here, which has pretty standard stuff. They're bringing in an iLogger. Notice dependency injection is working, so it's bringing in an iLogger so you can use it. And then down here, this is the fun one. This is the one that is where we actually see the method in action. So if you notice, we have a public override say hello method. That's because it's implemented in greeter base already. But in greeter base, if you'd noticed, it throws a new RPC exception if you try to actually use it. It says, hey, I've not been implemented. I'm unimplemented. And that's because you need to override each method in your services. You need to override each one with your own code. So in this case, we're overriding a say hello so that when say hello gets called, this method runs. Now, this is a very simple example where what's happening is it says when you get a request, just return task.fromResult, which means it's setting up a new task that just says, hey, just put the results in here. There's no delay or wait for it. And the reason why is because it wants to allow either synchronous or asynchronous calling of the same method. Now, the result is just a new hello reply, which that looks like a class, and it is. And notice over here, it just says string message, all lowercase. Over here, we have message, capital M. And the reason why it's different is because this is more of a JavaScript type feel where we have the lower cases, the camel case for things. But over here in C#, this is where we use Pascal case, which is the first letter of each word is capitalized. And so it does the Pascal casing for us when it uses the C# class conversion. So hello reply has one property called message, and we're just putting the hello and then the name that we've passed in. So here is the hello request. Remember that has one value in it, name. And so again, lowercase. We can say request dot name. That's an object where it's got a few values in here, but one of them is name, and name is the actual value we're looking for. So if we pass in Tim, it's going to reply back, hello, Tim. Now, if you were to launch this right now with all the demo code installed, you're going to get this. And it says, hey, I'm running actually on this web address, but it does not pop up a browser. Let me copy that. And if you go there, you see that communication with gRPC endpoints must be made through a gRPC client. That's a little easier to read. So it's saying you can't just browse to the URL here. That's not how gRPC works. It's not like an API where you can just call it and see the JSON values that come back, and even though it's not pretty, it at least gives you your values back. That's not how gRPC works. As the client, we need to have the contract as well and create the client side of our contract. So that's not going to work. So we need to create a client. Let's right-click on our solution and say Add New Project. I'm going to create a console application. And the reason why is because anything can be a client of a gRPC server. It doesn't have to be one particular project type. Console is just the easiest to do. But you could have a web app that is a gRPC client or a gRPC server even. But in this case, just a console, so we'll call this gRPC client to be clear as to what it is. And now we'll take out the hello world, and we're going to do a console.read line at the end just to stop it from closing. Now, there's a few things we have to do in order to get ready for gRPC in a console application or any type of application. And the first one is we need to add some NuGet packages. So there's 3 NuGet packages to add. First, you want to add google.protobuf. Protobuf stands for protobuffer or protocol buffer. That's going to allow us to work with those protocol buffer files. That's one. The next one is grpc.net.client. This allows us to actually talk to gRPC servers. And again, I'm using pre-release stuff because of the fact that .NET Core 3 is not quite out yet. And finally, gRPC tools. And this is going to allow us to have Visual Studio tooling that works with our settings. So that's the 3 NuGet packages. Let me show you those again so you can see them. That's the 3 NuGet packages you need to install. Okay, now we've done that. The next thing I'm going to do is right-click on my client and say add a folder. I'm going to call this protos. And this is the convention for where to put your protocol buffer or protobuf files. Now, remember I said that it's a shared contract. And I literally mean shared. As in, I'm going to right-click on my grpc server and say copy on the greet.proto. Come over to protos, right-click, and say paste. Now you can also point to the same directory for both of them. I'm not going to do that, but you could. And that would keep them fully in sync because they're pointing to the same directory, then they both have the latest changes. So now I have greet.proto copied over. Now here is the first place you're going to trip up. You need to make sure that you set the values for this, the properties for this, to be a protobuf compiler, public, compile protobuf is yes, and the grpc stub classes is set to client only. Now, my tooling gives me this error. Property value is not valid. This is one of those cutting edge, newer things that's causing a problem. So I hit OK and close out. Not to worry, because all of my settings for files are in my grpc client.cs proj file. Notice right down here, item group protobuf include greet.proto, and the grpc services equals server. That should be client. And hit save. So going to the properties would just set this for us through a GUI, but this is the manual way of doing it. I have also seen a bug where it says client here, but then it actually didn't have a closing tag here. It had it like this, like so. And then inside here, it had another tag that said, well, actually, it's server. That's wrong, okay? So make sure that it looks like this on your client, where it says client, okay? And normally, you should be able to set that to the properties for the greet.proto. But if it doesn't work, that's how you fix it. So that's one of those, it's going to cause you a problem issues. The next thing that's going to cause you an issue is when you start to, let's close all these out, all but this. So we have the program.cs open, and the next thing people try to do is start using it right away. But you first need to do a rebuild on your client. And the reason why is because it creates that file in the obj folder that has your client settings for this greet.proto. So now that we have that set up, we should be able to start working with our grpc server. So first we need to set up a channel. So var channel equals grpc channel, control dot to add the using statement, dot for address, we have to give it a web address. HTTPS, in my case, it's localhost port 5001. That's what the server operates on. Remember when I copied and pasted that into my browser, that was the URL. It may be different for you. And of course, you don't want to hard code this right into your C# code. You're going to want to put this into either appsettings.json or something similar so that you can change it at runtime depending on where your grpc server is located. All right, so next we set up a client. So client equals new, and then we have, this is where we basically kind of like instantiate our grpc server call. So new greeter, control dot to add using grpc server. Notice that's a using statement for this right here, but it doesn't have a reference to it. So it's a little bit tricky. It's got a using statement for it, but there's no reference to it. So new greeter dot greeter client. And you're going to pass in across the channel. So this is one of the ways that grpc is a little bit different. It tries to act like you are making a local call. So this equals new greeter.greeter client. It's acting like you're instantiating this over here, but you're not. What you're doing is instantiating the client, which is going to talk across this channel to call this on the server. So again, that's all set up for you in the background. So now you have a client, you can say, let's get the reply. So var reply equals client dot, and notice I have a couple of methods here, say hello and say hello async. Let's say hello asynchronously, because you could do it synchronously, but really everything across the web is asynchronous. So let's call it asynchronously, and we're going to await this. So we're going to await this, and we're going to say hello async, and it says, okay, I want you to pass in a hello request. Well, do we have one yet? No, not really. So I could say, let's create a hello request up above. So var input equals new hello request, and then we'll pass in the name equals Tim. Okay, so I've created this variable for us. So now you can pass that in input. Now it's still yelling at us because it says, hey, wait, the await operator can only be used in async method, but we're in static void main. Well, this is something that's been fixed in later versions of .NET. We can actually say static async task main, control dot on the task to add the using statement. And now this is an asynchronous caller, which means that we can call asynchronous calls. So now that we have the reply back, in theory, we've awaited for it. So now I can say console write line and just say reply dot message. And again, message is what they promise to send back in the reply. Now with this, we can just run this and it should work. However, we need to run both the server and the client in order for this to work. So how do we do that? Well, we right click on the solution and we say set startup projects, and we'll set both of them to be start. So multiple startup projects, set both to be start, and I'm going to move the server up one so the server starts first. We hit apply and we're going to hit run. And now I have two windows opening up. There's the server, there's the client. Notice the client already says hello Tim. So we look at the server side, we'll see execute endpoint grpc/greet.greeter/say hello. So it executed that and it request finished with a 200, meaning it sent back hello Tim. That's all there is to the basics of gRPC. We have a server that has a contract and it then has set up methods to handle servicing the contract. We have a client which calls the endpoints of the server. So that's the two sides of it. Both have this same copy of greet.proto. Now, what I'm going to do is I'm going to comment out all the client-side code, and I am going to basically ignore the server-side code, and we're going to set up a new service, a new gRPC service, so we can have, like from the ground up, what would happen. So let's start by going to let's close this out, and go to our gRPC server, right-click on Protos, and say, let's add a new item. And we're going to search for Proto. And that gives us a protocol buffer file. We're going to name this, let's name this customers.proto. Now this is Proto 3, And the namespace, I'm going to take the protos off. There's no reason to have that. I'm going to create a service customer. And notice the syntax is a little bit different. We have the curly brace on the same line as customer. That's more in line with a JavaScript type feel, and other languages do the same thing. So it is different, but my philosophy is to stick with what is conventional unless I have a really good reason not to. That way, people can easily read my code and it doesn't look jarring or different. And so I'm going to stick with the standards for how it's typically done. Okay? So I have a service called customer. I'm not going to put anything in here yet because I first want to define a few types to be able to use. The first type I'm going to create is a message customer lookup. I call it customer lookup model. And the reason I call it model at the end is because it makes it a little cleaner to understand and it doesn't step on toes. Because I want a customer object for my customer service, that's a problem. So customer model isn't a problem. So customer lookup model, and I'm going to say int32 user ID equals 1. Now right away you're saying, wait, what's int32? That's one of the available types to me. The common types are bool, int32, float, double, and string. All of them are lowercase. You may ask questions about things like date time or money. Both of those are a little trickier to do inside of gRPC. And that's definitely outside of the scope of what I can cover in this video, which is already going to be quite significant. But just know that there are ways of doing it, but it's not nearly as simple as what we're doing here. So int32 is a number. Often, what I will do is say int. I will forget, and this will not work. It has to be int32. Remember that this proto file is not something that Microsoft came up with. It is not something that Microsoft dictates how it lays out. This is something that is a standard that is used across the industry. And so it is different than C#. Okay, so we have an int32 for a customer lookup model. Essentially what we're going to do is have a way where you pass in and say, hey, I want this customer ID's information. So you pass in the customer ID of, let's say, 5, and you get back a full customer model. So that's next. Message customer model. Now I'm going to pass in a few different values, or have a few different values here, just to kind of show you what it might look like. So string first name equals 1, string last name equals 2. I'm going to have string email address equals 3. I'm going to have a bool is alive equals 4. And an int 32 of age equals 5. Notice when I say equals, that's just saying that number at the end is the order in which it is comes through. So 1, 2, 3, 4, 5. Those are the values. This tells the protobuf system how to, or actually gRPC, how to encode it and decode it so that it's sending through values in the correct order. Ordering is actually very important in gRPC. For our purposes, we really don't care. It doesn't matter what this ordering is. So just order it from number 1 at the top all the way down to whatever the last number is. Don't mix and match or try and change things up. Keep it in the correct order. Okay, so there's our second message. Now we can come up here and we can create a call. So RPC get customer info. We're going to pass in customer lookup model. And we're going to return, so returns, plural, customer model. Semicolon at the end. This is now our complete file. But I'm not quite done yet. I do want to add a second one, and I will do that in a little bit. But for right now, I'm going to say this is good enough. And what I'm going to show you here is the fact that you kind of want to create these proto files and be done and not try and come back and modify them over and over. But you can. And so I'll show you how to do that. So now that I've done this, I need to make sure this proto file is marked correctly. You're going to forget that at some point. So just try and remember. Properties, it's set to none. That's not right. Protobuf compiler. Now, if you don't see this, that means you don't have the grpc.tools NuGet package installed. And I want to set this as server only. So that works. I've typically not found a problem with setting this file to server only. It's when it's set to client only that becomes a problem. Now, if you notice, you can do a client and a server. It can go both ways if you wanted to. But for now, we're just doing a separate client from a separate server. Okay, so now that that's set up, we can do a build on our server, a rebuild. And this should build out the file we need it to. It's called customer. So I'm going to go to services, right click and say add class. And let's call this class the customer service. And the customer service should inherit from customer.customerBase. All right. So now just to follow the same pattern, we'll create a constructor and we'll pass in an iLogger so we can have that logger for use. Control dot, add a using statement here. iLogger of type customer service. Call logger. Control dot to create initialize that. And now we have our constructor. Do you have to do that? No, you don't have to. But you really should be logging, and so having your logger available to you is a good thing. Now that we have this, we can say public override. The nice thing here is with a public override, if I hit space, it now shows me what I can override. And the one I want is get customer info. So all that code that is now done. I don't have to type anything. So let's remove this right here and say customer model. That's what I'm returning. Customer model output equals new customer model. And then I have an if statement. I don't normally do this. I'm going to copy and paste code from my example just to save on time. And I'll talk you through it. It's really simple code. Essentially, if the request.userID, so that's what's being passed in, and user ID is the value being passed in. So if request.userID is 1, then populate it with Jamie Smith. If it's 2, populate it with Jane Doe. Otherwise, anything else, Greg Thomas. That's all it's doing. So it's a really simple simulation of what a database lookup might be. Okay, so that's where you'd probably do a database lookup. Return task.fromResult output. So this is doing that task.fromResult, which allows us to return a task type, and it can either be synchronous or asynchronous. So again, this is just dummy code, but it allows us to have a lookup that populates information. So that's the server side. And again, I am going to, before I do a build, I want to show you one more thing that's going to trip you up. I just added customer service. Well, if you go to startup.cs, come down here to our endpoints, I have a map for greeter service, but not for customer service. That would be a problem. Customer service. Control dot, like so. And it should be customers service. Oops. So let's rename this. And do you want to rename it everywhere? Yes, I do. So now it's customers service and it's customers service. Okay. So now it looks like we've got everything lined up. Make sure you add this mapping for any new service that you add. Again, that's another one of those things that's going to trip you up. There's about 6 of them on my list of things that's going to trip you up. Okay, now we can do our build gRPC server. Make sure it all builds. It does. Now we can go to our customers.proto, right-click and say copy. Right-click on protos up here and say paste. This is our client. Go to the properties for this, and it says server only. If I say client only, I still get that same error. No big deal. I click on the CS_proj file and just change this to client. Okay, so now I have this set up. Now what I can do is I can right-click on my client and say rebuild. Rebuild has succeeded. Now I come over here and I can make a call to that customers. So some of that's going to be the same. So var channel equals grpc channel for address, same address, and then I'm going to have a client. Let's do customer client equals new customer dot customer client for the channel. Notice how if you had both of these active at the same time, you wouldn't have to recreate the channel. You just have to have a different client per service. And now I can say var reply equals await client dot, and I have my options here, but get customer info async. And I pass in a value, which I don't have yet. Let's create that value. I could do it in line, but I really like to see it separately. So I'm going to say var input, var client requested equals new, and it is the, I forget, let's figure out the name is. It's going to be the customer lookup model. So new customer lookup model. There we go. And the user ID equals, let's start with 1. And that should be Jamie, I believe. And now I'll pass in the client requested. And this reply should be actually customer. So as customer, we can say console write line, and let's do our string interpolation and say customer.first name space customer.last name. Notice IntelliSense works just fine because it's an actual C# object. Let's run this. Notice both are going to be starting. Let's run this. I'll just pull over there's a server right there behind me, and there's the client, and it goes, no connection can be made because the target machine actively refused it. Well, that's just awesome. Okay. The first thing to do is to rebuild the solution, make sure it all builds. If it does, let's start it again before we panic here, and found there may be something going on with this server. It looks like the gRPC server is having a problem starting. So let's do this. Let's set this as startup project, just the server, and let's launch it again. I hit enter and now it starts. I think there was something where it was locked up. There's a problem when you click on the screen sometimes, it pauses the server. And I think it brought that pause across, and that was the issue. So now that it's starting, let's go back to solution, say set startup projects. We're going to start multiple. They're both already set as start in the correct order. And now we're going to start this again. I'll pull just the client over, and it says Jamie Smith. Now, if I were to stop this and I were to change this value to a 2, and I think this is Jane Doe coming up next. There we go, Jane Doe. So again, it's making that call to the gRPC server, and for the get customer info, it's getting the value back. So that's pretty cool. And that's how we'd work with our a new proto file and set up a new service. But there's more you can do with gRPC. One of the things it can do, I'm not going to show this entirely off, because again, I don't want to make this a huge video with hours and hours of content. I mean, I'd love to, but at the same time, you have better things to do probably. So let's add one more thing to our customer service. RPC, and this is going to be get new customers. Now, let's say the idea here is that you're a client and you're saying, you know what, I process clients. And so what I do is whenever I get a new customer comes in, I'm going to find that in the database, and I'm going to email them a welcome coupon or something like that. So the client is the thing that emails the welcome coupon. And it's going to ask the server, hey, are there any new customers? And that server's going to say, yep, here's the new customers. And there may be 0, maybe 1, maybe 100. It's going to pass those down to the client. The client's going to do some work on them. That's what's going to happen. Now, this is going to raise a few different issues. One of them is that we don't necessarily have anything to pass in. We're just asking, hey, are there new customers? In C#, we'd have no parameters. In gRPC, it's not quite that simple. Now, there are ways of doing it, but I have found the easiest and best way of doing it is to say message, and then let's just say new customer request, and leave it empty. Okay? And put that in for our value to pass in. It's an empty model. And then this returns, and I'm going to say it returns customer model. And we may say, well, Tim, that's great, but that's only one. How do you return multiple? That's a great question. And the answer is a stream. Now, you can also return arrays, and you can do that by saying it repeats. And so I could create another model in here. Let's just pretend it's this one right here. And I could say, I want a customer model, and you can say repeats. I believe it's repeats equals 2, like so. And that would have an array of objects. That's not what we're doing here. Instead, what we're doing is we're saying, I'm going to return you a set of customer model. I don't know how many that is, and it may not be instantaneous where I'm done giving you back the list. It may be that I'm going out to a database and chunking it, and so I'm getting 100, and I'm sending those down, but I'm not done yet. I get another 100, and I send those down, and I'm not done yet. I go back and get the last 43 and send those down, and then I'm done. This is where a stream comes in. This is one of the things that gRPC does well, is the idea of streams. You can stream in data, so I can say stream here, and I can stream out data, and that's what I'm doing right here. So I'm going to stream out customers. That's what I'm going to do. So I'm going to hit save on this, and I'm going to rebuild the gRPC server. Not the client, just the server. Now I'm done rebuilding this. I can come over to the customers service, and I already have my get customer info, but let's go to the end of this, and then let's do a new public override. And now I have get new customers. Now let's remove this right here. And one thing I'm going to do is I'm going to add async here. Whoops, not there. Here. I'm going to declare as specifically asynchronous. I'm going to paste in again some code just because who wants to see me type this out? I'm just creating a new list of customers, and I'm adding 3 new customer objects to it. Tim Corey, Sue Storm, and Bilbo Baggins with all of their data. Now with that being done, I have something to return. But how do I return it? Well, this is how. For each, var, let's do cust in customers. So how do you return this? You can't just say return customers. That won't work because you want to return a stream, which means you might not be done. In fact, you could do multiple for each loops and a whole bunch of other things. But notice here, let's unpin this. Let's actually make this a little bit easier to read. There's the three values being passed in. New customer request, that's the request being passed in, which is blank. There's nothing in there, but that's the object being passed in. And then we have response stream, which is interesting because that's different than what we see up here. We have the request and the context. That's the context down there, and that's the request right there. We have this new thing called response stream, and it's an iServer stream writer. So we can say response stream dot write async and pass in our cust. And actually, we should await that. So now we are sending one customer at a time down to the client. Now that would be fast, and it's not really as you may say, well, let's take a wait off and let's just write them all asynchronously. But really, again, ordering is important with gRPC. So allowing it to wait for the next value is valuable. But you already should have all your values in C#. But this way you could even read from a text file where you're reading line by line, and as soon as you read a line, you send it. Read the next line, send it. Read the next line, send it, and so on. That's all you do. There is no more steps. There's no return value because it's just a task, not a task of a type. It's essentially a void return type. And so what it's doing is saying, once this is done, this curly brace right here gets hit, that will tell gRPC we're done with this stream. Until then, the client will continue to listen for new customers. So that's how we implement a stream on the server side. Now what we need to do is we need to implement that same stream on the client side. So let's grab our customers.proto. I'm going to Control A here and copy. Then go to our customers.pro here, which is different. Control A and paste. That makes sure that those two files are in sync. Again, if you point to the same directory, the same files, then this wouldn't be a problem. Now it hasn't changed the type. So if I were to select the file and go to properties, it's still client only. And notice down here in startup.cs, I still only have these two services, but that's okay because I didn't add a new service. I just added a new value to the existing service. So now let's close everything out because it's going to be confusing otherwise. Let's open up program.cs. I am going to do a rebuild of the client. Make sure it builds. I'll leave this call here for the first part. And now I'm going to say that I want to just talk to the get new customers. So I'm going to say using, let's say var call equals client, which is, customer, client requested. There we go. Client requested. There we go. So this is our, customer client. This is where having client in your name 5 times may not be the best idea. You're trying to be specific as possible. You have the channel and then you have a client. Well, we're using this client, same client, because it's still the customer object. So client dot get new customers. You can pass in a new request model, a customer request model. There we go. And let's make sure I have my parens correct. I don't. I think that's correct now. So now that I have this call set up, I can say while await call.response stream .move next. So it's going to await this stream. There's a control dot here, I believe. Yep, grpc.core. So it's going to wait for the next item in the list until there's no more items, until it says, nope, I'm done. So while it's waiting, it's going to wait, and it's going to grab the next one. And it's going to, let's just say var, let's just do a current customer equals call.responseStream.current. That gets the current item in the response stream. And now I can say, let's do my my console write line, only as current customer. And let's do :space current customer.email address as well. Just so we have a little more value in there. Okay? So it's going to loop through every customer in the list. And again, this is a stream, so it's going to continue until that stream ends. Once it's all done, then we'll have received every customer that's a new customer. So let's do this. Let's put a couple of console write lines. Let's just say new customer list, and then another console write line like so. So we have a little bit of space between these two just to show there's some separation or difference there. Let's run this. Let's pull this over. And now we have our new customer list with Tim Corey, Sue Storm, and Bilbo Baggins. So it has asked the gRPC server, and it said, I'm going to stream down to you 0 or more items. In this case, it streamed down to us 3 items. And that's all there is to streaming. Now, it may seem like I'm just setting a list down, but what if that list took a little bit of time to get? So let's go over to Customers Service. And here, let's say that to get every customer, we're going to await task.delay of, let's just say, 1 second. So we're going to wait for 1 second before we give a customer. And the next one, we're going to wait a second and then give a customer. Just to kind of show how it might actually be if we're looking something up and streaming records down. Okay, let's start this again. Here we go. We have Jane Doe. Now we have Tim Corey. Now Sue Storm. Now Bilbo Baggins. Notice that delay that came between each of them. So it takes a little while, and that's okay. In fact, if we look at the time it took just over 3 seconds. 3 seconds, which with 24 milliseconds added on. So our 3 seconds was a delay. So it's the 24 milliseconds what it actually took. But that's how you would how it look if you were actually streaming real data. Like I said, if you're chunking data from a database, you might have some delays in there as it sent more. And that's okay. It can wait because that's what a stream does. It waits until this method is complete before it closes out that stream. So that's gRPC in a nutshell. That's how you get started in gRPC and start working with it. Now the question's going to come up, when would I use this? And I think for me, the answer is not often. And it may seem weird to go through an hour's worth of explanation to say, yeah, you're not going to use this that often. But it's one of those topics that it's got a lot of buzz around it, and there's a lot of people talking about it and building demos for it. But I think that the bigger question is, we have to think through is, when is this the right tool for the toolbox? It's a great tool to have in the toolbox. It's just the question should be, when do I pull that tool out? Microsoft has come up with a couple of different use cases for this that they're kind of pushing or talking about. One is when you are dealing with IoT devices, the Internet of Things devices. So devices that are really small, that might be bandwidth restricted, they might be memory restricted, they might be hard drive space restricted. Those devices might be a great candidate for this gRPC because it allows for really tight, small, quick communication between the client and the server and back. that stream might also be another really big benefit to an IoT device, which might have to stream back data rather than just sending over one piece of data or multiple pieces of data and being done. So that stream might be of value as well. The other case this might come up is in microservices. So microservices have to communicate between each other. Now, often this is done asynchronously and in near time but not real time using something like a message queue. But sometimes you're going to need to have a quicker or a need for a quicker communication method. So something where you get information really quickly. The illustration I have here is where I have a customer ID and I need more information about that customer. Maybe you're in the middle of a transaction with a customer and you need more information that the customer has to see. Well, that might be a time where you make a gRPC call versus creating an API for that call, and it might be a little bit easier or more efficient. So again, efficiency is the biggest thing I think that we should focus on for gRPC because it is more efficient than a web API. It can also be a lot simpler to make a small gRPC application versus a web API. There's a lot less footprint in some ways. Now, with that being said, the idea of sharing the protobuf file, that makes things a little bit more complicated. An API, you just say, call the API, there it is. Whereas if you have a proto file that gets out of sync, that would be a problem, and maintain that synchronization is something you have to think through. So at the end of the day, I would say that if you have a situation where you need the speed, you need the low amount of bandwidth transfer, or maybe you need some of that streaming capability, then gRPC is probably the right choice. But in general, if you need to share data across the web, it's probably a better and more full idea to use an API, because there's almost every web client can consume an API. Almost every desktop client can consume an API. Almost every mobile client can consume an API. It's not quite the same with gRPC. Now, you can have a gRPC server written in, let's just say we write in C#. You can consume that gRPC server with a client that's written in Java or Go or a number of different languages, because gRPC is a standard. And so there is that ability to have cross-application communication, cross-language communication in an easy manner. And in a lot of ways, on the client side, it feels like you're just making calls to a method. So there is that benefit of having the what feels like an extension of your application, when in reality, it's a different application and maybe even a different language. Okay? So that's the overview and the start of gRPC. Give it a try it out, see what you think. I would love to know in the comments down below what your thoughts are, where you might see yourself using this, and what questions you have or thoughts you have about gRPC. Okay? Thanks for watching, and as always, I am Tim Corey.